Hello, everyone. In this video, we talk about a very important data science library known as Pandas. A Pandas data frame is built on top of NumPy arrays, providing a more flexible and labeled interface for working with the structured data. So to see the connection between Pandas data frame and NumPy arrays, you can think about it through this very simple example where let's say we have a 2D array where we have in the first column information about age and in the second column information about city, right? So we have a data set where we have 3 rows and 2 columns. And in this case, let's say that the first row corresponds to Alice, the second row Bob, and third row corresponds to Charlie. So in NumPy array, we don't really have a good way of labeling, and we usually have to resort to the standard indexing in Python, which means that, well, the first row is index 0, the second row is index 1, and then the third row is index 2, and the same thing with the columns. But what is really helpful if we can actually label this data set or this 2D NumPy array. And in that case, we can create an object which is called a Pandas DataFrame. So as you can see here right now, this is very much like an Excel file or a spreadsheet where we have these labels for each column. So we know that the first, for example, the column here, we have this name label and then age and then city. And also for each row, we have these names. So this means that if you want to retrieve information about Alice in this, data set that we have or data frame, we know that we can just call the name, right? And remembering that Alice corresponds to the first row of this, NumPy array. So that's why we really want to use Pandas data frame in data science and machine learning problems because it makes it much easier to be able to access information, filter information, and other things that we're going to very briefly discuss. So as we just discussed, each column in a data frame can be considered as a one-dimensional NumPy array, right? So for example, here, the age column, you can see that this is actually a 1D NumPy array, which contains 3 values, 25, 30, and 35. And therefore, the entire data frame is a collection of these 1D arrays, right? So you have these collections of these 1D arrays for each column where we put them all together. Now we get the pandas data frame. And as mentioned earlier, each column in the data frame has a unique name. So that's like very important here, this labeling process, which allows for easy identification and access. But sometimes we want to also access information in the rows of this data frame. They also have labels, as you can see here, and we call these, in this context, mainly an index. So index is what we use for the labels or names that we use for the rows, and for the columns, we just call them column names. So let's just get started with the first data frame. And in this case, we're going to first create a NumPy array and then use this method, which is called .DataFrame, to convert this NumPy array to a pandas data frame. So in this case, the main thing that we have to do is to import pandas. And it is common to use an alias. We use import pandas as pd. We use import NumPy as np. So you can see that we are building on the libraries that we know. So now we know very two important libraries, NumPy and pandas. We also know about like matplotlib. So we are getting to know more and more libraries that are helpful for data science. And in this case, as we said, we want to create first a 2D NumPy array. So you can see that now we're going to have 3 rows and 4 columns. And to emphasize this, if we have just this NumPy array, now we have to remember what each row and column corresponds to here, right? But the point that really is important to consider is that when we use pandas data frame, and that's what we are doing here, we are trying to convert this to the NumPy array to a pandas data frame, we have to provide these column names and also these index labels that we have, right? So remember, index here is technically what refers to the rows. That's what the official terminology that we use. So this means that because we have 4 columns, we need 4 column names: math, English, science, and programming. So these are, let's say, 4 courses that each student can take. And then the index here is a list of 3 elements because we have 3 rows: a student 1, a student 2, a student 3. We can, provide any strings here, but that's what we have used in this case. And at the end, I'm going to just print what's inside this data frame. And you can see that this is exactly what I showed you earlier, right? So you have this nice data frame with the column names and these index labels, right? That's what we call them, these index here, what shows what these rows are. Okay, so now let's say we are given this data frame and we want to access data that we have in this data frame. So let's say you want to find out the grades for all the students in the math class that we have here. So in this case, you can use df and then the name of the column, right? So here basically would be df and the name of this column is math, and we can access this full information. There is another way of doing this too, which is this dot notation, df dot, and then the column name. I definitely recommend you to use the first approach where you just use these square brackets and column name or column name. So you can here also provide a list of column names if you want to access more than one column. So as you can see here, if I use df math, you get 85, 92, and 78, right? So these are the scores that we have for this math class across all rows or here students. And if you want to retrieve 2 columns, now we provide this list of the 2 column names, and you can see that we get this information for math and English. The other thing is that sometimes you want to access a row, and in this case, you have to use the index for those rows with this method, which is called df.loc or LOC. So that's the difference between accessing rows and columns. For accessing columns, you just use the name of the data frame, a square bracket, the column name. But if you want to access a row, you have to first say whatever the name of the data frame is, .loc, and then you provide that label index. So as you can see here, if I want to retrieve grades for a student 2, then I can use df.loc a student 2, and we get this information: 92, 88, 95, and 75. Remember, what we have here is just a subset of this data frame. So when you say df.loc, we actually have to look at the df data frame, which is this one. So you see that that's why we get this 92, 88, 95, and 75. So sometimes you want to also do a data manipulation, for example, add a new column to a data frame. And this is very easy. You just need to use df and the name of the new column that you want to create, right? So there's nothing called total before, but let's say we want to add that information. So you just say that, well, I want to have this new column. And in this case, you have to assign something to that new column, right? So we are saying that we want to use df.sum access 1. So what does this do? Remember that, when we are working with multidimensional arrays, we have something called an axis, which shows the direction that we have the information. And so very similar to what we have in NumPy. So axis 0 is this axis, and then so this is 0, and axis 1 is this one, right? So if you want to find the total sum for each student, so you want to perform this summation across the rows of this data frame. So that's why we have to use axis equals 1. So that's something that we inherit from NumPy. So we use the same indexing for axes. So based on that, now we can go back to the cell where we wanted to find this sum. And you can see that when I print this data frame, so you can see that we get the sum of these 4 numbers in this new column, which is called 345. And then similarly for the other rows here. So the nice thing is that you don't have to apply these individually. So you can just say that I want to add all the elements in each row and assign the corresponding value to this new column, which is called total. And so now that we created this, let's do something interesting. And let's say that we want to sort these values in this column, which is called total. And in this case, we can use this built-in method, which is called sort values. So when you say the name of the data frame dot sort values, you can use the syntax we have here. So the first one is by, which is the column that needs to be used when you want to sort these elements of this data frame. So here you want to say that I want to sort these students based on their total score. You can do this based on their math score or any other sort of like columns you want here, but it makes sense in this case to do this based on the total column. And then the axis by default is 0, which means that you have the vertical axis because we want to sort them based on this information that you have in this column. And then you can also decide if you want to do this ascending or descending. So by default, ascending is equal to true. We set this ascending to be false, right? So if you see when I run this cell, what's happening here is that now these grades are actually, because ascending is set to be false, now they are in descending form. So meaning that you have the highest number first, which is 351, and then you go to the lowest, which is like 345. So this is very helpful if you want to just visualize if you have a large data set and you want to see the distribution of data in a sense from maximum to minimum. You can sort this as students, right? So student 3, based on what we have done, has the highest score based on all the courses that we have here. But something else that is important here, you can see that once we do this sorting, if I again print the data frame, you can see that we lost the sorting that we have. And this is a very important concept when working with data frames, is that some operations are not going to be permanent. And the terminology we use for this is in place. So in place equals false here means that this sorting does not change the original data frame and it just creates a copy of that. But if you want to perform this in place, meaning that by setting in place equals to true, then this means that the original data frame will be modified. And therefore, from now on, whenever you have data frame here, you can see that, you will get this one that we have here that is sorted, not the original one. So this is kind of like your preference, whether you want to modify your original data frame. In many cases, it's better not to do that because you may need the same ordering as you received before. But in general, you have the option to decide whether in place should be false or true. So here you can see the information about all these parameters that we have in this syntax. The other important thing that we want to do with data frames, because in general, you may have a lot of information about different students, users, depending on what the data frame is about. And you want to just look at a subset of this data frame, right? So again, let's go back to our example. And let's say for whatever reason, you only want to include students in your analysis that they have received more than 90 in their math class. And so in this case, what we can do is to use this comparison operator, saying that I want to look at this column, which is the math column, and see whether it's greater than 90 or not. So in this case, you can see that we should get false, we should get true, and false, right? Because only the the student 2 is the one that has a score greater than 90, and the other two ones are below 90. And so very similar to, again, what we did before with Python lists or NumPy arrays, you can use these Boolean values to do indexing. So this means that if I just use these Boolean, values that I received before inside this data frame, so use the name of the data frame, a square bracket, and what you get here, these Boolean values, this will, in this case, understand that you want to only keep the ones that are equal to true, which is only the second row, and you get this information about student 2. So again, this is a very simplified case, but you may have hundreds of thousands of rows in a data frame, and using these can easily filter this data frame without you going through them individually. So it's a very helpful strategy to use this type of indexing, where you put some condition on one of the columns, or it can be more than one column too, and then you fit that again to the data frame to select the ones that are equal to true. There are also a lot of more functionality here. For example, one of them is this df.plot. So in general, we learned about matplotlib in the previous lecture, and you can, select the data that you want, convert that to a NumPy array. We're going to talk about this very soon, and use matplotlib. But the point that really here is important is that data frames also come with some plotting options, and you can just say like the name of the data frame dot plot, and then the kind of plot that you want. So you want a line plot, bar plot, a scatter plot, histogram plot. These are things that we talk about it in the in the matplotlib data visualization lecture. But if you don't want to directly use a matplotlib, there are some functionalities here for visualization in data frames. And you can see that here we are saying that I want to plot the data frame and I want to use the bar plot. And I call this, you can provide a title to a student scores. So you can see that in this case, we get this very nice plot where for student 1, we have the grades for each individual course and then the total. So this can be very helpful because you do not have to do this manually. So it's kind of like a very low code approach. You can also create other plots too. For example, a scatter plot. Remember, with the scatter plot, you need to have X and Y values because you have 2D coordinates. So in this case, we want to say that on the X-axis, I have math scores, and the Y-axis, I have science. And so you can see that in this case, we get 3 data points. Each data point, you have the math score and the corresponding science score, right? So that's something can be very helpful to visualize the relationship between grades in these two classes, right? Is there any relationship between your math score and science score? The other thing that is kind of important to understand when working with data frames is handling missing data. And in general, for missing data, we use nan or not a number or null values. So this shows that there are some missing values. So for example, let's say for some reason you do not have information about one of the students' grades. So in that case, you cannot just put 0 or some random numbers. You have to have a very specific way of saying that, well, this number is missing, and that's why it is not a number or null value. And in order to check whether you have these null values, you can use this dot is null or is an A. And also then you can, on top of that, you can use dot sum to find the count of missing values. So let's create this example where we have a data frame with 4 columns and 3 rows. So I intentionally use this example to show you that in order to create a data frame, you can actually use a dictionary. So this data right now is a Python dictionary where you have this key value pairs. And if we just convert this to a data frame, you can see that each key here now is a column, right? So A is now the first column, B and C. And these values here are basically the values that we have in the rows. And since we don't have any index labels that are the default indexing, which is 0, 1, 2, 3. But you can change this if you want, right? And provide the index labels. But for now, let's just use these. And for nan, you're using np.nan. So if I use df.isNull, you can see that we get true wherever we have a missing value, right? Like similarly here, and we get false when we do actually have some values. And the same thing with is and a, right? So that's, you can see that it's the same thing. And so if you want to now find the total count of missing values per column, you can see that now you can use dot sum. And this tells us that we have one missing value, right, in column A, one missing value in column B, and no missing values in column C because they're all false, right? And this is because when you have, summation applied to Boolean values, false is equivalent to 0 and true is equivalent to 1. So adding these numbers will tell you the total number of trues or missing values that you have. And in general, when we go to like machine learning and statistical methods, in many cases we cannot fit these missing values to, like, let's say, a machine learning algorithm, and therefore we need to either drop them or fill them with some other values. And one of the approaches is to use this drop and a. You can see that in this case we have this data frame. If I use drop and a, we are going to remove the rows that they have missing values. So this row with index 1 has a missing value, so it's not here anymore. And the same thing with this one, right? That you have a missing value, and so it's gone. And so we only keep the first and the last row in this case. This is more common to do this row-wise because we want to get rid of samples that they have missing values. But if for some reason you want to remove columns that they have missing values, meaning that column A and column B, then you can change the axis. And remember, axis again is very much like we had in NumPy. Axis equals 0 is the vertical axis, and axis equals 1 is the horizontal. So in this case, you can drop the axis 1, and you can see that we only keep column C. But remember, all these operations by default do not modify the original data frame, which can be a good thing because you may want to know exactly where you had missing values, or if you want to use the other information that you have for each sample. And therefore, in this case, what we used did not modify the original data frame. The other option to handle missing values is to fill in these missing values with either a specific value, right? If you want to exactly, for example, here say that, well, anywhere is missing, just you fill that cell with value 4, right? So you can see that now we have 4 here and 4 here. These are the missing values that we had to just show you. Or you can use actually like some more advanced operations here. For example, you can say that I want to use the mean or average of samples in each column to fill these missing values, right? So you can see that in this case, this was our missing value, and now we have 1, 2, 4. So if we add all those numbers, we get 4 plus 3, which is 7, and then divide by 3, which should be this number, right? So that's how you fill this information using the average values of non-missing values. The other operation that we can use when working with Pandas DataFrame is something called group by. And I think this really tells you what this is. So this is used for grouping rows based on some criteria and then applying a function to each group independently. So the syntax is relatively simple. You use df.groupBy, and then you provide this by argument. So this is very similar to the case where we wanted to do like sort values, right? We had to provide the column for that. But in this case, this is a column that we want to use in terms of identifying criteria for grouping. And usually after that, you also want to apply some aggregation function, meaning that for all those columns that or rows that are in the same sort of like, column, do you want to find the sum, mean, count them, you want to perform some aggregation function. So let's say, create an example to understand this better. So again, I create a dictionary, and then we provide a data frame using pd.DataFrame. So you can see that here we have information about the students, class, scores. Something that is unique here, there's some student names that you see that we have more than 2 times. Like Alice, for example, has this class A and B, obviously with 2 different scores. Similar with Bob, but Charlie, it seems that has only 1 class. So in this case, what you really want to do is, for example, saying that, well, even if a student has taken more than 1 class, I want to just look at the average score across all classes. So if the student has only taken 1 class, that's the score. If it's more than 1, I want to take the average. So here you just say that for this data frame, so you're going to look at the 2 columns, a student and a score. We are going to group by the student column. So now we group them based on their this name. So Alice will be grouped based on these 2 rows, Bob similarly, and then you're going to apply that mean, right? So in this case, Alice has one with a score 85, the other one 90, and so the average would be 87.5. And you can see that here, if I run this cell, that's exactly what we get here. So for Alice, we get 87.5. For Bob, has 2 scores, 92 and 88. If you take the average, it will be 90. And Charlie has 1 score only, right? So this is very helpful if you know that you have multiple rows per, let's say, user, customer, or a student, and you want to perform some aggregation function on those grouped rows. Something else that we want to cover here is combining data frames. So we had a very similar idea in NumPy. You can see all the connections now between NumPy and Pandas. In NumPy ND arrays, we had the option to concatenate arrays using np.concatenate. In this case, we have a similar thing too, where we can use the concat function to concatenate, combine 2 or more data frames. And you can do this along a particular axis. So you can see that the syntax has these like objects, which is a sequence, which means a list or dictionary of data frames that you want to concatenate. And the axis is either 0 or 1. So 0 means that you want to concatenate things vertically, and axis 1 means that you want to concatenate them horizontally. So usually the more sort of like common approach is to concatenate vertically using axis 0. That's why this is the default value, because you may have, like, let's say, different students, different users in different files, and now you want to combine them together. So here we create these 2 data frames, df1 and df2. So you can see that df1 is this data frame and df2, right? So they have the same columns, and then obviously different values inside them. So here I just decided to assign them some strings, but again, this can be some numbers, etc. And if you use pd.concat, and then we provide a list of these arrays axis 0, you can see that now we are going to combine this vertically, right? So we have this part, and then this A3, B3, C3 right under the first part. But you can see that here, one issue that we have is that the index labels that we have for the rows, now they are kind of like conflicting, because we had 0, 1, 2 for one of them and 0, 1, 2 for the other one. So there's no like direct way of knowing that, well, we have to change them. So there are multiple options to handle this. One of the options is use the reset index method. As you guess, this reset the index label. So now means that we're going to start from 0 to whatever number that we have here. And if you want to change this to something more helpful or useful, I would say, you can use set index, right? So you can see that we provide 6 values here. And if I run this cell, now we get these index labels N0 to N5. So you have a lot of options in terms of changing column names, changing index labels, and also concatenating different data frames. But I would say the most important part of this lecture is here because in general, when you're doing data science, you don't want to create your own data set, and instead you're given a data set. And one of the most common formats to actually store data sets is this CSV format, comma separated values. So in this case, for example, you can open this life satisfaction file, which is a CSV file, and you will see these values that are separated by commas. So it's really hard to read that if you just open that CSV file as it is. Obviously, you can open it as an Excel file because it has, as you have seen today with the data frame, these data frames are very much similar to Excel files and the spreadsheets. But anyways, you are given a CSV file. This is very common. And in this case, you want to convert this to a data frame. So there is a special method to do that, and that's pd.read_CSV. So it's very easy to remember. And there's also this index call here, which, as we have the information here, this tells you that, the index the index of the column that has to be used as the index row or the row labels for your data frame, right? So in this case, when you're given a CSV file, you have the option to decide what actually is the row labels that we have for our data frame. And in this case, we are saying that that information is inside the column with index 0. So if you can run this cell, now you can see that we get this information that is included inside this CSV file. So we have these column names, country, GDP per capita, life satisfaction. So in this data set, the goal is to find out whether there is a relationship between GDP and life satisfaction in a country. So you can see that this is a data frame where you have 27 rows. It starts from 0 to 26. Very similar to NumPy arrays, you can use dot shape, and this tells you that you have 27 rows and 3 columns. And just to show you the difference here, because again, it's very important to experiment with the code. If you, for example, choose index column to be 1, so now you can see that that sort of like, row label or index label is actually like country, right? So this means that if you want to use that .loc method to recover information for each row, now you can provide these names. So that's why it is kind of like important to decide which column here is actually your row labels. So in this case, it makes sense to use index column 0 to make sure that we get these integers that we have here for the indices of the rows or the row labels, and then we have this information. But again, there are some degrees of freedom here, and what we really look for here is to find a relationship between GDP, gross domestic product, and life satisfaction. So a very useful method in data frames is .describe, and this provides basic statistics for your data set. So here you can see that the 2 main columns, GDP and life satisfaction. So we only get these 2 because these are like, numerical values. If you look at country, we have strings. So therefore, we cannot really find the minimum and maximum value. But for the numerical ones, you can count the total number of elements, the mean or average, standard deviation, and then distribution information, minimum, maximum, percentiles. So for example, here you know that just by using df.describe, that the minimum value for life satisfaction is 5.4, and the maximum is 7.6. So from a data scientist perspective, that can be very helpful to figure out like what range of values you have for life satisfaction in your in their data set. And also you can use other methods too, for example, like df.info. The nice thing is that this one will tell you whether you have missing values. You can see here it says none null, meaning that you don't have any missing values. It tells you that the country, the data type is object. And then for GDP and life satisfaction, you have float, say 64. So these are like floating point numbers and the amount of storage you need. So in this case, this is a fairly small data set. But if you have a huge data set, you may want to know whether, you need like, 200 megabytes or 2 gigabytes, right? So you want to have that information. So now we can practice some of the things we discussed before. So let's say you want to filter this data set to find countries where their GDPs are greater than 40,000, right? So you use this Boolean sort of like, or a comparison operator to get Boolean values. And then you feed this to DataFrame to do the filtering. And you can see that in this case, we are now only, accessing or working with, the part of the data frame where the GDPs are greater than 40,000. And that's exactly something we can confirm here by looking at the GDP column. If you want to, we can convert this data frame to a NumPy array, because sometimes we do not want to keep this information anymore about the column names and row labels. We are ready to feed this data set to some machine learning algorithm. And in this case, you can use the two NumPy method. So if in this case, we are selecting two columns and then using two NumPy, and this will, give us, in this case, a 27 by 2 NumPy array. And we know that this is NumPy array because we can use the type. So you can see that NumPy.nd array. And just to see inside here, you can see that this is our 2D NumPy array. Also, in this case, if you want to plot or have a scatter plot, we can do this. So we can plot the first column of this array versus the second column, right? So these are the x coordinates, these are the y coordinates. The way we can do this using NumPy is that we select all the rows and then the first column, all the rows and the second column. And you can see that now whether we have any kind of obvious relationship between GDP and life satisfaction. We are going to work this from a machine learning perspective, but immediately you can see that based on a very simple data analysis that we have done here, that there is actually a positive correlation between GDP and life satisfaction. And in this homework, we're going to work with a CSV file, which is called iris.csv. This is provided to you, and make sure that this CSV file is in the current folder or directory. If not, you will get an error message that the interpreter cannot find this CSV file. So if you get any error message like that, you need to make sure that you put it in the same directory. And then the idea here is to start working with data frames, like loading this data, displaying the first 5 rows, printing the summary statistics that we just discussed. In this case, because it's a classification problem and we have 3 species of iris flowers, you can use value counts to count the number of samples per class. And then we want to create some scatter plots similar to what we have done here to figure out whether there is any relationship between these different columns. And also we want to perform some operations such as displaying samples or rows where, like, let's say petal length or one of the features is greater than some numbers. So this is the filtering part that we mentioned. Also, we want to create new columns such as like sepal area, petal area, etc., where we want to, for example, operate on 2 or more columns and assign the value here. So this should give you a good sort of like practice for working with Pandas data frames. And this is something that we're going to use a lot for the rest of this class when we use machine learning algorithms.